then we need to find the correct ascending order of electronegativity of carbon atom of the given compounds. Okay, so can you remember what are the factors that affect the electronegativity of an atom in a given compound? So the first factor is the hybridization of the atom, in this case of the carbon atom. Then formal charge of the atom. Finally, the next factor, the oxidation number of the atom. So what's the next one? The neighboring atoms. Let's check one by one. First one, formaldehyde, HCHO. So central atom is carbon, 2 hydrogen atoms are there, 1 oxygen atom. Hydrogen, a single bond, oxygen, a double bond. So there are 3 sigma bonds with 1 pi bond formed by carbon atom, which means the hybridization of carbon atom in formaldehyde must be sp2. There are 3 sp3 hybrid orbitals. Those 3 hybrid orbitals can form these 3 sigma bonds, and remaining 2p orbital can form the pi bond. Then what about the next one? It is formic acid. Carbon, hydrogen, there must be an OH group. What is the reason? The basicity of this formic acid is 1. Therefore, one hydrogen atom can be released as a hydrogen ion. Therefore, it is bonded to the oxygen atom in the acid molecule. So, valence of oxygen is 2, valence of hydrogen is 1. So, 3 sigma bonds with 1 pi bond. Therefore, hybridization is sp2. Next one, hydrogen cyanide. Central atom, carbon, there is an hydrogen atom, there is a hydrogen atom. Valence of hydrogen is 1, valence of nitrogen is 3. So how many sigma bonds are there? 1, 2. How many pi bonds are there? 1, 2. So carbon has formed 2 sigma bonds with 2 pi bonds, which means the hybridization must be sp. There are 2 sp hybrid orbitals. They can form 2 sigma bonds. Then remaining 2 p orbitals can form 2 pi bonds. Then finally, carbon dioxide. Central atom, carbon, 2 oxygen atoms are there. Valence of oxygen is 2. 2 sigma bonds with 2 pi bonds. So hybridization is sp. So we know that when the hybrid orbital is shorter, the electronegativity of the atom is higher. So sp hybrid orbitals are shorter than sp2 hybrid orbitals. Therefore, it is clear that when we consider carbon atoms, the electronegativity of carbon atom in hydrogen cyanide and carbon dioxide are higher than the electronegativities of carbon atoms in formaldehyde and formic acid. So we need to compare these two and these two separately now. So next factor is the formal charge. So according to these Lewis structures, it is clear that formal charge of each of these carbon atoms are 0. So then we need to bother about the oxidation number of carbon atom. We know that electronegativity of carbon atom is higher than the electronegativity of hydrogen. Therefore, due to this carbon-hydrogen bond, the oxidation number of carbon atom is -1 because electrons are attracted to the carbon atom. Due to this carbon-hydrogen bond, oxidation number is -1. When we consider carbon and oxygen, electronegativity of oxygen is higher than the electronegativity of carbon. Therefore, electrons are attracted to the oxygen atom. Therefore, the oxidation number due to this carbon-oxygen double bond is +2. So, overall oxidation number is 0. Due to this carbon-hydrogen bond, oxidation number of carbon atom is -1. Due to this carbon-oxygen double bond, oxidation number is +2. Due to this carbon-oxygen single bond, oxidation number is +1. So, overall oxidation number of this carbon atom is +2. So, when oxidation number increases, electronegativity increases. So, we can write that the electronegativity of carbon atom in formic acid is higher than the electronegativity of carbon atom in formaldehyde. So, what about hydrogen cyanide? Due to this carbon-hydrogen bond, oxidation number of carbon atom is -1. Electronegativity of nitrogen atom is higher than the electronegativity of carbon atom. Therefore, electrons are attracted to the nitrogen atom. Therefore, oxidation number of carbon atom due to this triple bond, carbon-nitrogen triple bond is +3. So, overall oxidation number is +2. So, what is the oxidation number of carbon atom in carbon dioxide? It's +4. So, it's clear that the oxidation number of carbon atom in carbon dioxide is higher than the oxidation number of carbon atom in hydrogen cyanide. Therefore, electronegativity increases in the order of, when we consider the carbon atoms, hydrogen cyanide, carbon dioxide. So, the correct increasing order of electronegativity of carbon atoms of the given compounds is formaldehyde, formic acid, hydrogen cyanide, carbon dioxide. That means the first one is the correct answer for this question. So, when we write answers to this question, there is a shortcut. When we consider these two molecules, this portion is common. So, we don't need to bother about that one. Then this is a carbon-oxygen bond, this is a carbon-hydrogen bond. So, due to carbon-hydrogen bond, electrons are attracted to the carbon atom. Due to carbon-oxygen bond, electrons are attracted to the oxygen atom. So, definitely oxidation number of carbon atom in formic acid is higher than the oxidation number of carbon atom in formaldehyde. So, we can deduce the variation of electronegativity using that variation without deducing the exact oxidation number. Similar thing can be used in this situation also. Carbon hydrogen bond, so there will be a negative oxidation number, carbon nitrogen, but we know that the electronegativity of oxygen is higher than the nitrogen. Therefore, definitely oxidation number of carbon atom in carbon dioxide molecule is higher than the oxidation number of carbon atom in hydrogen cyanide. Then we can deduce the variation of electronegativity.